Welcome to the first true building block of application security. Before you can defend an application, run a penetration test, or set up a secure delivery pipeline, you must master a small set of words used every single day by security professionals. These words are asset, threat, vulnerability, and risk. They look simple, but people confuse them constantly, and that confusion leads to bad decisions, wasted effort, and unprotected systems. This course defines each term precisely, shows how they connect, and gives concrete examples you can rely on for the upcoming quiz. Why vocabulary matters. Security is a discipline of prioritization. You will never have enough time or money to fix everything. To decide what to protect first, you must be able to describe what you are protecting, what could go wrong, where the weakness is, and how serious the consequences would be. Each of the four core words answers one of those questions. When you use them correctly, your reports, your test plans, and your conversations with developers and managers become clear and defensible. 1. Asset. An asset is anything that has value and that you want to protect. In application security, an asset can be tangible or intangible. Examples of assets: data, customer records, passwords, credit card numbers, health information, source code, cryptographic keys, systems and components, a web server, a database, an application programming interface, API, a container image, a build server. Processes and capabilities: the ability to process online orders, the availability of a login service. Reputation and trust: the confidence customers have in your brand. A useful way to think about an asset is to ask, if this were stolen, altered, or made unavailable, would it hurt the business or the users? If the answer is yes, it is an asset. Assets are the reason security exists. Everything else in the vocabulary revolves around protecting them. Security professionals often describe what they want to preserve about an asset using three properties, known as the CIA triad. Confidentiality: only authorized people can read the data. Example: keeping medical records private. Integrity: data cannot be altered without authorization or detection. Example: an attacker cannot change a bank balance. Availability: the asset is accessible when needed. Example: the website stays online during a sale. 2. Threat. A threat is any potential event or actor that could cause harm to an asset. A threat is the what could go wrong or who might attack. Importantly, a threat is a possibility, not a certainty, and it exists whether or not you have a weakness. Threats can come from different sources: malicious human actors, threat agents, cybercriminals seeking money, competitors, insiders such as a disgruntled employee, hacktivists, or nation-state groups. Accidental human actions: a developer who accidentally publishes a password in public source code. Natural or environmental events: a fire or flood destroying a data center, affecting availability. Technical failures: a hard drive crash, a power outage. A distinction to remember: a threat is the potential harmful event, while a threat actor or threat agent is the person or thing that carries it out. For example, the threat is theft of customer credit card data. The threat actor is an external cybercriminal. Examples of threats in application security: an attacker attempts to steal session cookies to impersonate a user. An automated bot tries thousands of stolen passwords. Credential stuffing: a malicious insider copies the customer database before leaving the company. 3. Vulnerability. A vulnerability is a weakness or flaw in a system, application, process, or configuration that a threat can exploit to harm an asset. If a threat is what could go wrong, a vulnerability is the open door that makes it possible. Vulnerabilities can exist in many places. Code flaws: a form that does not check user input, allowing an injection attack such as structured query language injection, SQL injection. Configuration mistakes: a database exposed to the internet with a default password, or a cloud storage bucket left publicly readable. Missing controls: no limit on failed login attempts, allowing brute force attacks. Outdated components: an old software library with a publicly known flaw. Human weaknesses: employees who can be tricked by phishing emails. A key point: a vulnerability by itself does no harm. It only becomes dangerous when a threat can reach and exploit it. A weakness in a system that no attacker can access is much less concerning than one exposed to the whole internet. Example: an application stores passwords without encryption. The vulnerability: the threat is an attacker who gains access to the database. If both exist, the passwords can be stolen. 4. Risk. Risk is the combination of a threat exploiting a vulnerability and the impact it would cause. Risk answers: how likely is this to happen, and how bad would it be? Risk is the concept that lets you prioritize. A common and simple way to express it: risk equals likelihood x impact. Likelihood: how probable it is that a threat successfully exploits a vulnerability. This depends on how exposed the vulnerability is, how skilled and motivated the attacker is, and whether protective controls exist. Impact: how much damage would result, such as financial loss, legal penalties, downtime, or reputation damage. Because risk requires all the pieces, you only have real risk when a valuable asset, a credible threat, and an exploitable vulnerability come together. Example of the full chain. Asset: the customer database contains personal data. Threat: a cybercriminal wants to steal and sell this data. Vulnerability: the application is vulnerable to SQL injection. Risk: high, because the data is valuable, high impact, and the flaw is easy to exploit over the internet, high likelihood. If you fix the SQL injection flaw, the vulnerability disappears and the risk drops sharply, even though the asset and the threat still exist. How the four terms fit together. Think of it as a sentence. A threat exploits a vulnerability to harm an asset, creating risk. You can reduce risk in several ways. Reduce the vulnerability, fix the flaw, patch the software, add input validation. Reduce exposure to the threat, restrict network access, add authentication. Reduce impact, encrypt data so a stolen copy is useless, keep backups. You usually cannot remove threats entirely, since attackers and accidents will always exist. That is why security work focuses heavily on reducing vulnerabilities and limiting impact. Related terms to know. Exploit: a specific technique or piece of code that takes advantage of a vulnerability. Attack: the actual action of a threat actor attempting to cause harm. Control, or countermeasure: a measure that reduces risk, such as a firewall, encryption, or multi-factor authentication. Attack surface: the total set of points where an attacker could try to enter a system. Mastering these definitions gives you a shared language for the rest of the course, where you will identify vulnerabilities, model threats, and prioritize your tests and fixes based on real risk.